So we are going to use our TI-84 graphing calculator to see which algebraic model comes closest to this data, and this data shows the profits made in millions of dollars by a company, all right, from between 2004 and 2011. And for sake of convenience, we are taking the years t as the number of years since 2004. So here this corresponds to t equals 0, this corresponds to t equals 1, and likewise 2011 corresponds to t equals 7. So what we have to do first is that we go to stat and see I have entered the data in here already, and so in the first column I have these values, the values for t, and in the second column I have the values for L. And after entering them, I would do this. Let me just get it again, show you how I got it. I went to stat, go to calc. Okay. Now we want the exponential regression because that's the one that we were asked to fit in here. So if we do that, this is exponential regression. So it tells me that the equation of best fit in this case, the exponential equation, is a times b to the x, where a is 1.24381 approximately, and b is 1.4194. So the equation will be of this type, that is, you will have y equals 1.24381 times 1.4194 to the power x. All right. Actually, in this case, t, but we are going to put that in our graphing calculator, or the graphing calculator talks about it in terms of the powers of x. Okay. Then the next thing that we would do, let me just get Excel back here. One moment, please. Okay. So then we go to y equals option. Okay. And then we do this, that is, first turn the plot on and then enter this equation that we have here in for y1 if that slot is open. And now remember this, your window is like t values go from 0 to 7, the y values go from like 1.2 to 14.1. So let's adjust our windows. Well, 0 to 15 is okay here, and then in here we will, let's put that as 0 to 25, because in the next part we are being asked to use just the graph to determine the year in which the profit will reach $22 million. So anyways, first let me do all that, and here you can see that we have the scatter plot and then we have the equation. Now we have to determine the year in which the profit will reach $22 million, right? So what we do is we go back to this graphing window and print 22 in here. And if you look at the graph, we have to determine the x coordinate for this point, which will be t here. And of course, we have to round it to nearest whole number, and we can read it off from here. But let's use the intersect feature here. So we have this. So it asks me, is the first curve this? I said yes. For the second curve, we have 22. And then it's going to compute that for us in slightly iterative manner. So intersection is 8.2 approximately. Okay, so that means that when t is 8.2, then the profit will reach about $22 million. So 8.2 in this case, your work has been to round up so that we can say that in terms of year, that when will the profit really be 22 million. So here we can take 9 and add it to 2004, so we can say in 2013 the profit will exceed 22 million, and of course it will be 22 million a little after 2012. Okay, now let's see how we can solve this problem analytically by using logarithms. So we are working with this equation, and I wrote t here instead of x because that's what we were using in the original equation. And what we have to do is we have to solve this equation for t, and t is in the exponent. Now remember, we have our function log with the property that if we apply log on m to the power p, then the value is p times log m, or log is going to pull the exponent down here as a factor. So we are going to use logarithms to get a solution of this equation. Okay, so here we go. We have this equation. So what we will do, as in the case of any equation like this, our first task is that divide both the sides by this, so that we are as close to isolating t as possible. Okay, so we have this 4831. Okay, and then what we will do next is that let me just write it in a way that it's easier to align. Okay, I mean there's nothing wrong before, but let me just write it like this: 1.24831. Okay, now we will take logs of both the sides. So we will take log of this side, and that equals the log of this quantity, right? And because of the power property of logarithm, t is going to do what? Step down as a factor. And so our next equation will be what? T is out there. Let me erase it here. Okay, now we are ready to solve for t, right? T is multiplied with this quantity, so we can go ahead and divide by the quantity right here by this value right here, because that is not equal to 0. And you can use your calculator, or that this is going to be approximately 8.2. And if we did this, that if we went to the calculator, that will give us the same answer. Okay, that is what we have here, log of, right, 22 divided by 1.24831. Okay, and this whole thing divided by who? The log of 1.4194, and that's like about the same value that we got here. Okay, so do it any way you would like, unless you are being asked to follow a particular way. Okay.